Okay, today we're going to do the final case of Chapter 8, and you know it as interval estimation for one mean. So, case 4. And this is the proportion case. So here I got a human resource consulting firm. They conducted a survey of 1,100 employees at medium and large size companies to determine how dissatisfied employees were with their jobs. You don't need this part because I took the textbook's data set and made it random, right? So now when you hit F9, what happens? Every time you hit well, in your case on a laptop function F9, right? Every time you hit F9, yeses and nos change, don't they? So what do we have to do to prevent that from happening? Right click on column A, copy, right? And then right click again on column A and paste special. Now everybody has a frozen set, right? A frozen sample. We each have a unique sample of 1,100 employees. Now there's a couple ways we can get the point estimate. What's the point estimate? What am I talking about when I say point estimate as opposed to a point estimator? To you guys it sounds the same, right? A point estimator sounds the same as the point estimate. Let me know the difference between the two? A point estimator and a point estimate. Let me ask you this question. How do you calculate a sample mean? Ashley, how do you calculate the mean? Describe how the procedure used to calculate a sample mean.
You take the average of the sample.
And what does that mean? What does the average mean?
You take all of them and add them together and divide them by
the number. Okay, so in Greek or in an equation form, it'd be x bar equal capital sigma x divided by square root of n. Or in Excel, it would be equal the word average and then parenthesis, right? Right? That's the procedure. Now, when you apply the procedure to data, what do you get? You get a number, right? The number is the point estimate. How you got that number is the procedure, or the point estimator. The point estimator is the procedure. The point estimator is the procedure.
So what's the point estimate?
The point estimate is the number, the actual number that you get when you apply the procedure, or the point estimator. And I'll show you right here. Now there's a couple ways you can do the point estimate, right? We can do a count if statement, right? I'm going to make some room here. Okay, so I can do equal count if what? What am I counting here, Johnny?
I'm actually not sure.
We're counting yeses, right?
Okay.
We want to count yeses. So the first thing we have to do when we type count if with the equal in the parenthesis, right?
We just highlight the whole.
We highlight the data. Now what I'm going to do is I'm going to click on that first one, right? You guys see that? And then in a PC, I'm going to hit Shift and Control and then the arrow down button.
Shift.
Control Shift and arrow down. That's a quick way to get all the data in a column in Excel. You see that? It's faster than using a mouse and then pulling it down, right? Because you'll overshoot, or you might go too slow, and the next thing you know, you need to get up and get a cup of coffee because you're still going down the row, and it's 15 minutes later, right? So Control Shift and arrow down to get all the data. Now, if I hit a comma up here, what's it asking for? A criteria. How many different categories do I have for this variable? Two. I have yes or no. So if I want to count yes, what do? I type yes. Is that good? Got to use quotations, right? Because if I don't use quotations, what do I get? I get 0. And obviously there's not 0 yeses there, right? So you have to use quotations. Why do I say that? Because Excel's going to treat yes as a variable. In this function, yes is a variable. I'll show you. I'm gonna define this cell. I'm gonna name this cell. I'm gonna name it yes. And then I'm gonna put the word yes in there. That's cool.
Capitalize yes when it's in quotation marks?
Try it.
Because
Yeah.
mine's not working.
Did you guys see that? This cell is called yes now, right? It's named yes. It's also known as B11, right? I could have named the cell, hang on a second. I could have named the cell John. Johnny B. Well, I'll just call him John B. John B. Okay, I can't have a space. I'll just call him John. Right? And then I go to, this is kind of fun. I need to go to the name. I'm having a little fun here. Where's the name? The formulas. Define name. Oops. Name manager. I'm going to get you rid of yes. What happened? This cell's no longer named yes, it's named what?
John.
John. So what I can do is I can change this to John, right?
Sure.
See how that works? That's why you have to have quotations around yes in the command itself. So I'm going to change this to yes. Chandler, did you need to have it capitalized?
Yes.
Okay, if you don't have it capitalized, what does it do?
It gave me a name.
You can have it capitalized or not. It doesn't matter.
I had to capitalize mine when they gave me my number.
Oh, really?
Yeah.
Okay, so maybe it's just a different version of Excel. So what does this number 562 mean?
There's that many yeses in the data.
Exactly. And then how many were there? How many were there?
1,100?
Yeah, but I'm gonna double check. I'm gonna type count.
1,101.
I'm gonna do count, and again, I'm gonna do shift control and arrow down. That way it gets to the end of the data, right? So there, it didn't count. Count A?
Yeah.
Oh, count attribute? Okay, good, thank you, appreciate that. In the past, I just had to have count. So now I guess you have to have count A.
So this is, you did say earlier this was all random data, so
Yeah.
my number of yeses shouldn't be the same as yours, right?
Exactly. How many people have more than 562 yeses? You can raise your hand if you want. It helps me out. So Chandler and I have the most number of yeses. Okay. How many people? Then everybody else should have what? Less than. So everybody else needs to raise their hand when I say this. How many people have less than 562 yeses? Wow, Chandler, we're on the top. We're on top here, man. Because being on top.
My grade's on top.
So, do we win anything by being on top of the number of yeses? No, it's just a random thing, right? It just so happened I ended up being on the top of the distribution, right? So how do you get the point estimate of the population proportion? That right there is the freak of yes, right? The frequency of yes. How do I get the relative freak of yes? How do I get that? The relative freak of yes. Don't you wish your freak was a relative freak like me? Don't you? How do you do that? What do you do? We want to take the freak, right, and do what? Divide by the total, right? That's a relative freak, and that's a freak.
Do that. Will you click on your
Yeah.
other? Yeah, thank you.
It's a relative freak because, a relative frequency, because we're dividing the frequency by the total, right?
Okay.
And what is this called? What's the name of this thing? Is it the proportion of the population of employees who strongly dislike their current work experience? Is that what it is? Is it that? Or is it the point estimate? If this were the proportion of the population, we'd all have the same number, right? And everybody that worked at these medium to large companies would be in our study. But that's not the case here, is it? We only have 1,100 people in our study, right? Yeah, Cassie.
So the 0.51 that you have on your screen is the point estimate.
It's the point estimate of the population proportion.
Okay, and so what you did to get that was you said 562 divided by
1100. Yeah.
Okay.
So what is the procedure or the point estimator? The point estimator is the what?
The best guess of.
Well, the point estimator is the procedure. We counted up the number of yeses. We divided that by the total sample size. That's the procedure.
What do you mean by that?
Well, how did I get the 562?
You counted up all the yeses in your.
Okay, that's the procedure, right?
Okay.
So the procedure is to count the yeses
Mm-hmm.
and then divide that frequency by the total. That's a procedure, right?
Okay.
That's the point estimator. When I apply the data to that procedure, I get a number which is the point estimate. That's the point estimate.
Okay.
The procedure we used to get that estimate is the point estimator. The procedure is the point estimator. Or the point estimator is the procedure used to compute the point estimate. So this right here, we call this P bar. P bar. So P bar, X bar, P bar. We say P bar, we say X bar, right? But rather than saying P bar, we call it the sample proportion. Okay, sample proportion. AKA P bar, right? This is also known as the point estimate of the population proportion. So it's got a bunch of names, right? Sample proportion, P bar, point estimate of the population proportion. So P. Diddy, pun intended, P. Diddy is a little jealous, isn't he? Because he's known as Sean Puppy Combs or P. Diddy. Well, wait a minute. He's also known as Diddy, right? So he's got three names. P. Bar's got three names. P. Bar's three names are what? Mr. Point Estimate of the Population Proportion, Sample Proportion, or P bar. His buddies call him P bar, right? So he's got three names. His formal name, the point estimate of the population proportion. His buddies call him P bar, and then his mom calls him sample proportion. And this is the estimate of a thing we cannot know. What's the thing we cannot know, David? David's not here? Derek. What is the thing we cannot know here?
Actual population.
The actual population proportion, exactly. Now, we don't give it a Greek letter. In the book, they don't give it a Greek letter. But when I write my textbook for this class, I'll call it pi. Because pi is the Greek letter for P, and P is for proportion. I like to have all the things that we cannot know in Greek letters. Because only the Greek gods know what? Mu, sigma. In this case, P. I prefer pi for that reason. And then the betas from chapter 15. Betas are just slope parameters or coefficients. So the thing we cannot know is the population proportion. Now, I'll go around the room and I'll just point and you guys tell me what your proportion is. What do we got?
To what decimal place?
Huh?
To what?
We'll go 3 decimal places. I'll start right here and then I'll work myself around the room. And say it really loud for the audience. What do you have for a proportion?
I have 0.501.
Okay.
497.
497. Cassie?
0.495.
0.523.
0.498.
0.505.
0.533.
0.482.
0.492.
So what do you guys think? What would be a good guess for the true population proportion?
0.5.
Probably 50%, right? Do we know that for sure? No. So what we're going to do here, we're going to build a confidence interval. We're each going to build a confidence interval, right? And that confidence interval is going to tell us whether most of the people dislike their jobs in New York City, or if half the people like their job, half the people dislike their job. Or it'll also tell us whether most people like their job. Okay, what's another way we could do this? I'm going to create a variable called D, and I'm going to write, if you guys want to go along with me, equal if. I'm going to hit the left arrow key, and I'm going to put equal yes. So if the thing in cell A2 equals, quote, the word yes, unquote, then assign the value 1, else 0. So when I hit enter, what am I going to get in the cell?
0.
0. I'm going to get 0. Well, I'm going to get 0 because mine's no.
And you get 1.
So I'm going to get 0, right? So that 0 means what? Well, let's read it again. If the thing in A2 is the word yes, then 1. What's in my A2?
No.
The word no. So it's not going to be 1, right?
So then that's the value of.
Yeah, so this comma means what? What does that comma mean in English? Then assign the value of B2 the value 1. This comma means what? Assign the value to the cell that we're in, assign it the value 0. That's what you get. And now how do you get all of them?
You just highlight it and you scroll it down.
Or quicker, there's a quick way to do it.
Okay.
See, normally it's a white cross. If you put it on the corner, you'll get a black cross. Once you have a black cross, double click. Boom, you have them all. If I apply the point estimator x bar to this variable, what is x bar doing? The procedure x bar, sample mean. What is that procedure doing to this column of 1s and 0s? It sums the 1s and 0s, right? And then divides by 1100, correct?
And then that tells you how many yeses and nos you have.
The proportion of yeses. Because if I sum this, what is it basically doing? When I add 0 to something, I get 0. But every time I add 1, it goes up by 1, right? So when I apply the x bar procedure or the point estimator procedure for the sample mean to this column of numbers, 0 plus 1 is 1. 0 plus 1 plus 0 is 1. 0 plus 1 plus 0 plus 0 plus 1 is 2. What's it doing? It's counting the yeses. And then it's, at the end, when it's after it's counted the yeses, by summing the 1s and 0s, it divides by 1100, right? So another way to get the sample proportion is to apply the procedure for x bar to the 0s and 1s. And you get the same number, right? So we can do the count if, right? Divide that by 1100 and we get the p bar. Or we can convert the variable, the yes and no's, to 1s and 0s, and then apply the x bar procedure to the resulting numerical values. So I'm going to just make that one yellow and red because that's the answer, right? This is what Cengage now is maybe asking you for, right? So that when I put a yellow box there, that's the answer blank. Imagine that's the answer blank in Cengage now. Now at 95% confidence, what is the margin of error? What do we need for the margin of error? In a proportions problem, it is no different than a sigma known problem, except you're not given the sigma. You have to compute the sigma. Okay, you have to compute the sigma. So this is how you compute the sigma. Here I got a sample of data. I got 10 people. I asked 10 people who they voted for, right? I convert it to a column of 1s and 0s just like we did in the case, right? I apply the x bar procedure. I call it p bar here because we're summing dummy variables. We're summing the dummy variable, 1s or 0s. So when I sum that up, I get 1 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 0 plus 1, which is 6. 6 people voted for Obama, so P bar here would be 0.6. This is the sample proportion. And you guys recognize this? This right here is x minus mu squared. And then sum them all up, divide by n. So what am I doing here? I'm applying VAR dot P. I'm applying VAR dot P to my data, right? VAR dot P. So if I apply VAR dot P to my data, I get the sigma squared for a proportions problem. Are these equivalent? Are these the same numerically? How many of these reds do I have? If I sum 1 minus 0.6 squared 6 times, what can I do? I can just multiply that by 6, right? And then I have 4 of these. So I can do 4 times this, or I could do that, plus that, plus that, plus that, right? You guys see that? Now what is 6 divided by 10? 0.6. What is 4 divided by 10? 0.4. So that's where this 0.6 comes from. That's where this 0.4 comes from. Now where does this 0.4 come from? What is 1 minus 0.6?
That comes.
What is 1 minus 0.4? 0.4, and it is squared. Where does this 0.6 come from? 0 minus 0.6 squared. So this right here is that guy. This right here is that guy. And the 6 divided by 10 is that guy. And the 4 divided by 10 is that guy. Okay, now I can factor out how many 0.6s do I have here?
2.
I have 1, right? How many 0.4s do I have? 2. But how many 0.4s do I have here? 1. How many 0.2s do I or 0.6s do I have here? So what can I factor out? I can factor out 1.6 and 1.4. 1.4 and 1.6. What am I left with here?
0.4.
A 0.4. What am I left with here?
6.
6. Now what is 0.4 plus 0.6? 1. Now what do we call that? That's P bar. What is this? 1 minus P bar. So sigma squared is, you can find sigma squared by doing what? Applying VAR dot P to the data. This up here is just VAR dot P, right? When you type equal VAR dot P, parenthesis, highlight a column of data, what is it doing? This, right? Or you can do what? Multiply P times 1 minus P, right? You guys got that? So a proportions problem is a sigma known problem, but you have to calculate the sigma from what? P, right? Your proportion. The same case now, you might not have the underlying data. So you have to do it this way, P times 1 minus P. In our case, though, we can do either way, right? The case, we have P bar. We also have the 1s and 0s. So let's go back to here. So we need our sigma squared, right? I'm going to type S squared and then equal. I'm going to change that to superscript.
Are you
You have to click on the thing in the cell, and then you can format cells, and then up here you pick symbol. Symbol is a collection of Greek letters. So in the PowerPoint, what can we do to get the variance? If you know the P bar, what do? Tyler.
Close call.
Close call, huh? I got 2 Tylers in here. Tyler, what do?
when you take this input?
I'll go back to the PowerPoint.
So P
Times
1 minus
1 minus P. I don't got P, but I got P bar, right? So P times 1 minus P. Whoop. P times 1 minus P. Now what about down here? Can I use the equal VAR dot P formula? What is this right here? This right here is doing this to the data, right? Doing this to the data. VAR dot P first does what to the data? VAR dot P first calculates the sample mean, or the mean, and then does what? Then it does this to the data. So if I add the data, I can actually type, I want sigma squared, right? The proportions problem is a sigma known problem. But you have to calculate the sigma squared first. So I'm going to type equal VAR dot P, parenthesis, I'm going to get all the data and hit enter. Notice I get the same thing. So I can either use VAR dot P, Excel's VAR dot P function, or I could just multiply P times 1 minus P. Cassie, questions? Now your numbers are going to be different than mine, right? Because you have a different sample. Right? Now what do I got to do? I got to find what? Have I found the margin of error yet? Okay, now what do we do that we have the sigma squared? What do we do now? Taylor, what do we do next?
Square root.
Square root. We want the sigma, right? We have the sigma known problem. Do we use Z or do we use T? Z. So let's go back to the PowerPoint and fast forward. So this is the sigma known problem. Why is this a sigma known problem? Why is it the sigma known problem? Cassie. Very simple. Why is it sigma known?
Is it because of the standard deviation?
We know the population standard deviation, which is named the population standard deviation, right? Sigma known means we know the population standard deviation. And this is for a sample mean. We're trying to estimate the interval for the population mean. We're trying to get a worst case scenario and a best case scenario for the population mean. Remember, X bar is going to vary from sample to sample, right? So given that we've calculated 1 X bar, we want to use that X bar to kind of figure out a worst case and best case scenario for the population mean, right? So we're using this confidence interval to estimate the population mean, a range for it, a neighborhood.
Okay.
The population mean is in this neighborhood. Okay, for a proportions problem, you use P bar instead of X bar, right? Mean, use X bar. What's the difference between P bar and X bar? Well, P bar, you're adding up a bunch of ones and zeros, right? And you're dividing by n. What do you do in X bar? You're adding up a bunch of male heights, and you divide by the sample size. Or you're adding a bunch of incomes up and divide by the sample size. But in P bar, you add a bunch of ones and zeros and divide by the sample size. Proportions problem is always what kind of problem? Z or T?
T. Or Z, sorry.
It's a Z problem. As long as n is greater than or equal to 5 divided by P, another way to say that is n times P is at least 5. Or n times 1 minus P is at least 5. You can use the standard normal table. How do we get the margin of error? We have to find the Z, right? We have to find the Z. So we need 1 minus alpha. Shelby, you're here. What's the 1 minus alpha equal to? Alpha is the area in the tails. 1 minus alpha is the area in the hump of the distribution. It's 0.95, right? So what does A equal to, Shelby? 1 minus 0.95. How many numbers do we have in a confidence interval? Nick,
What?
how many numbers are in a confidence interval?
2.
2. So what do you do with the alpha?
Oh, yeah, divided by 2.
Yeah, because there's 2 numbers in a confidence interval, right?
Right.
So what's the Z alpha divided by 2?
1.96.
1.96, right? And Chandler wanted to know how to do that. You go to my website, you find the ZT chi-square and F table, and you find 0.025, right? 0.025. it's in row 1.9 and column 06, right? So 1.96. What's the margin of error? Schaefer, what is this ratio called?
Oh, the standard error.
That's the standard error, and this is and the whole thing is the confidence interval. Okay? So you take Z times sigma divided by square root of n. And n is 1100 here, right? So this is Z. And this right here is the standard error that's in gray. The standard deviation divided by square root of n. When I multiply by the Z value, I get the margin of error. Any questions on that? And then we have the lower limit and we have the upper limit, right, of the confidence interval. So, Emily, what's the confidence interval? What do you have to do? There's two numbers, right?
Yeah, you have to take P bar and add it to the margin of error or subtract it from the margin.
Okay, so you P bar plus or minus the margin of error. So on the lower limit, P bar minus the margin of error, and then P bar plus the margin of error. So, can we say most people dislike their job? If both these are above 0.5, we can say most people really dislike their job. If both these numbers are less than 0.5, we can say most people like their job. But because one number is bigger than 0.5 and one number is less than 0.5, you can say half of the people in New York really dislike their job.